Hey class, Mrs. Spencer here. I'm going to go through the very last section of your algebra review for the ACT. So we should be on this page, page 25. It's the last piece of content we have in this section. So pause your video if you don't have this out, turn your packets to this page. We're going to go very quickly through a review of how to solve systems of equations. If at any time I'm going too fast, just pause the video and you can get caught up. Remember, this packet and your homework packet will both be due on Friday. I'm going to go through and grade for completion and for work shown and stuff on your homework. So the first method we can use to solve a system of equations, which just means we have more than one equation, is to use the elimination method, to eliminate one of the variables by adding the equations together. It says sometimes you may need to multiply one or both of the equations by a number to get the variable to eliminate. So let's look at an example of this. We are going to solve 3x plus 5y equals 13 and x minus y equals negative 1. In order to use the elimination method, we need these to be opposites. So we need either these to be opposites or these to be opposites, meaning it would be like 3 minus 3 or 5 minus 5. We want to get one of these to cancel out when we add them together. So the best way to do this is to multiply your bottom equation by 5. This is going to make your y cancel with that y. Okay, we're going to have a 5y minus 5y, and those will cancel. So I'm going to do that, multiply the bottom one by 5. Top one stays the same. And at this point, I will add them together. So 3x plus 5y is 8x. By design, these cancel. That's what we wanted to happen. Equals 13 minus 5 is 8. The nice thing about the elimination method is we only have one step to solve this now. We just divide by 8 on both sides, and x equals 1. In order to find our y value, in order to complete our solution, we have to take this and plug it back into one of our equations. You can choose either equation. I'm going to choose the top equation because they're all positive, and I just really like to work with positive numbers. If you choose the bottom one, you'll get the same answer. So I'm going to try the top. 3. In place of x, I put 1. I'm looking for y, so I leave it as a y. And I'm going to solve this. So 3 times 1 is 3. Subtract 3 on both sides. I'm going to write little here. So 5y equals 10. And we divide by 5. So y equals 2. Most of the time, whenever you're solving a question like this, you're going to write your answer as an ordered pair. X, comma, y. And this is my solution. This is one method to solve, and sometimes questions are set up very nicely to use the elimination method. Other times they're not, and it might be better to use the substitution method. So let's go down to the number 2. It says isolate a variable in one equation, then substitute that expression into the other equation, and solve. So let's do an example. 3x plus 2y equals 10. X equals 5y minus 8. In order to do this, it says isolate a variable in one equation. That is already done for us right here. Isolate means to get it by itself. That's by itself. So I can take the expression that x is equal to, and I can plug it in up here in the other equation for x. This will become 3. In place of x, I have 5y minus 8 plus 2y equals 10. I'm going to distribute my 3, and I'm going to solve this for y. So 3 times 5 is 15, y minus 24 plus 2y equals 10. Combine my like terms here. So 17y minus 24 equals 10. Add 24 on both sides. 17y equals 34. And I'll divide by 17. And y is 2. This takes a little more work than I think this did up here. But to plug it back in, we have less work. Because I'm going to take this and plug it in here for y. And it's already solved for x, so it saves us a little bit of time. X equals 10 minus 8. X equals 2. So my solution for this system is 2, 2. We're going to skip the graphing calculator method for now because we won't have graphing calculators in the room today since I'm not at school, but we'll come back to that. It's a cool method. Whenever you have a system of equations, you could end up with 3 different answers. You could end up with a point, which is what happened in both of these cases. This means that the lines intersect. So we're looking at something like, here's one, there's the other, and there's our point. No solution would mean that the lines are parallel, meaning they never intersect. And infinite solutions means that the lines are the same, meaning they share all points with each other. They're right on top of each other. Draw it extra bold. Those are the 3 different cases that could happen. So these other 2, no solution and infinite, are also possible. All right, if you have any questions with this, I'll be happy to clear those up when I get back on Friday. Please use this time to finish up your math packet, meaning if you need to copy some notes from a day you were gone, feel free to ask maybe your neighbor. They might let you borrow them. Get those caught up, and then also work on your homework packet. Make sure every section is done, including the part that is for systems of equations. So this is the math packet. You'll work through whatever you don't have finished here. Try to show some work. If you didn't on some of them, go back, have work shown. That's how you're going to get your points for this. Awesome. I will see you on Friday. Thank you for being kind to the sub, and have a great rest of your day. Thanks.